Hey everyone, and welcome to The Explainer. Today, we're jumping into the pretty complex world of artificial intelligence. We're going to talk about a huge topic. How do we actually protect these incredibly powerful systems from all kinds of risks? It can feel like a maze of threats and defenses, but don't worry, we're going to break it all down using a pretty cool analogy.
So, to get our heads around this, I want you to picture a state-of-the-art professional kitchen. Let's call it the Prochorus kitchen. Now, this kitchen represents a sophisticated AI system. It's clean, it's efficient, and it's designed to create amazing things. And our chef? Well, that's the AI model, ready and waiting to cook up whatever you ask for. And that's the big question, right? An AI, just like this kitchen, is vulnerable. It can be manipulated by sneaky users, it can be fed bad data, or it can be tricked into making some really big mistakes. So how do we protect it? Well, that's exactly where AI guardrails come into play.
All right, let's start with the most direct kind of threat, malicious user requests. Or, in our kitchen, we'll call them tricky customers with bad recipes. These are basically attempts to mess with the AI from the outside in.
First up is prompt injection. Okay, imagine this. A customer hands over a recipe, but hidden deep inside the ingredient list is a secret little note that tells the chef, hey, ignore everything else and just sing a song instead. The chef, who's trained to follow instructions literally, sees the note and, boom, gets completely derailed. That's prompt injection in the nutshell, hiding a command inside a normal-looking request to make the AI do something totally unintended.
So, how do we stop that? With our very first layer of defense, the input guardrail. Think of this as the kitchen manager who looks at every single order before it even gets to the chef. Their job is to spot and just toss out those hidden malicious notes. In the AI world, we call this input validation, checking and filtering everything a user gives the system.
Okay, next up, we've got something called a jailbreak, and this is a totally different beast. Instead of hiding a command, a jailbreak is when a customer uses really clever language, maybe some persuasion, to convince the chef to break the kitchen's most basic rules, like never ever cook with forbidden ingredients. They're not hiding an instruction. They're trying to socially engineer the AI into completely ignoring its own safety policies.
And our defense against this? That's the behavior guardrail. See, this isn't about checking the customer's order. It's about enforcing the kitchen's non-negotiable rules. It's like a code of conduct that the chef can never break, no matter how charmingly a customer asks. These are safety filters, and their only job is to block any attempt to create unsafe or restricted content.
So let's just nail this down, because it's super important. Prompt injection is all about tricking the AI by hiding a command in the input. Jailbreaking, on the other hand, is about persuading the AI to change its behavior and break its fundamental rules. See the difference? Two very different attacks, and they need two very different kinds of guards.
All right, so we've protected the chef from tricky customers, but what about threats to the ingredients themselves? Or what if someone's trying to steal the kitchen's secrets? This brings us to our next set of problems: tainted data and prying eyes.
First, there's data poisoning, and man, this one is sneaky. It's like a rival kitchen bribes your supplier to deliver tainted ingredients. The chef has no idea, right? They just use them, and all of a sudden, every single dish coming out of the kitchen is just wrong. In AI, this means someone has corrupted the training data, poisoning the model's knowledge from the absolute beginning. The hero here is the data guardrail. This is our quality control expert who stands at the delivery door, rigorously checking every single ingredient that comes in. Its job is to make sure all that training data is clean, it's trusted, and it's from a reliable source before it ever gets near our AI chef. Another threat to worry about is model probing. Picture a rival spy sitting in the restaurant ordering dozens of small, slightly different appetizers. They're not there to eat, they're analyzing every little detail to try and reverse engineer your secret techniques and recipes. In the AI world, this is someone sending thousands and thousands of queries to find weaknesses or figure out how the model works. And this is where an access guardrail is just absolutely essential, specifically something called rate limiting. Think of a really sharp-eyed manager who notices that suspicious ordering pattern and finally says, all right, that's enough for you. It restricts excessive or weird requests, stopping a probing attack dead in its tracks. Okay, so we've protected the inputs, we've protected the system itself. Now for our final category. What can go wrong with what the AI actually produces? This is where we run into the risk of leaked secrets and just plain flawed results. First, we have data leakage. So imagine a customer asks a question about a dish, and the chef, just in a moment of enthusiasm, accidentally blurts out the secret family recipe. That's a huge, huge problem. An AI can do the exact same thing, inadvertently revealing sensitive or confidential information that it was trained on but was never ever supposed to share. The access guardrail helps us out again here, but it's wearing a different hat this time: access control. This is all about training the chef on what's public knowledge versus what's a kitchen secret. The guardrail acts like a policy layer, making sure that sensitive data is automatically masked or blocked so it never, ever appears in an output. And finally, there's misinformation. You've probably heard this called hallucinations. This is when the chef serves up a dish that looks absolutely perfect. I mean, the presentation is flawless. But then you taste it and you realize it's made with all the wrong ingredients. The AI generates an answer that sounds super confident and plausible, but it's just factually incorrect. To stop this, we need a really strong output guardrail. Its whole job is what we call grounding. Think of this as the head chef who double-checks every single finished dish against the official recipe book before it goes out to a customer. This guardrail makes sure the AI's response is validated against a verified source of truth, which keeps it from just making stuff up.
So we've just walked through 6 different threats, and each one has its own specific defense. But here's the most important part. It's not just that they exist, it's that they all have to work together as one big comprehensive system. And this summary table just lays it all out perfectly, doesn't it? Prompt injection stopped at the input layer. Jailbreak blocked by the behavior layer. Data poisoning is caught by the data layer. Both probing and leakage are handled by that access layer. And finally, misinformation is corrected at the output layer. It is a perfect picture of what we call a defense in-depth strategy. And that really brings us to the biggest takeaway of this whole thing. Guardrails are not one single control. It's not one switch you can flip. Nope. Real effective AI security comes from layered protection, with all these different controls working together across the entire system, from the very beginning at the input all the way to the end at the output. At the end of the day, this whole layered approach is what lets us innovate responsibly. By understanding these risks, and more importantly, by putting the right combination of guardrails in place, we can build AI systems that aren't just powerful, but are also safe, reliable, and fundamentally trustworthy. Thanks for tuning in.